I'm a math secondary trainer for Northwest Regional Professional Development Program.
And I am an instructional coach from Sparks Middle School. And Holly and I came together on this project because I had some math teachers come to me and say, "Hey Deb, I need you to help with constructive response." And of course I acted like I knew what I was talking about, and I said to them, "Sure, no problem. Let me get some stuff together and I'll come right back to you." I had no idea, none at all. So I called Holly and I said, "Hey Holly, can you come over and teach my math teachers about constructive response?" And Holly said, "Hey, well, you know what, let's do it together." And I said, yeah, no, that wasn't what I was thinking at all. I was thinking you could come over and teach my math teachers about constructive response, because I'm an English type. And Holly kept saying, "You know what, Deborah, seriously, we could do it together." So she came over and we came up with a plan. We actually worked a lot with Baldridge. We had just finished Baldridge training, so we got a lot of our information from them. They had a really great training. And so we sat down, decided how we were going to do it. We introduced it to my math teachers. They loved it. Mm-hmm. They emailed us, "Hey, you guys ought to share with other schools." We were going, "Oh, okay." So I guess it's too late for long story short, but long story short, my English teachers heard about this and they said, "You know, I thought you were an English type, Deborah. What's this? You do it for math? What about us? Where's the love?" So Holly and I got together again. We came up with a plan for constructive response in language arts. Of course, then the science teachers come in. "Excuse me, what about us?" So we got together, came up with a plan for science. And this is how, and I know history teachers, your time is coming. Yeah. We
You're
promise.
Next.
But so far, we've come up with a plan for how to teach constructive response for math, for language arts, and for science. And we hope you guys enjoy it.
One of the things that Deborah and I thought about as we were at a training together from Jim Shipley and Associates, and we loved their material, but the material they gave out to us was missing the most important thing, which was a gimmick. And when you deal with any sort of students, whether they are secondary or elementary, a gimmick is what sticks in your mind. So Deborah and I had to do some serious reflection and decided that we were going to take it to the 100th millionth level. We're both very type A personalities and we enjoy going over the top with our students. So when we came up with this whole process, it comes with a presentation that is easy for the students to understand. So if you can imagine Deborah and I presenting something like this in a classroom, where the students get to be a part of the action and they get to really remember it. So first of all, we would start with when they entered the room, we would be playing love songs. We're wearing red. Both Deborah and I are wearing red. It's all about love and it's all about hearts. And of course, on our desks would be these beautiful love centerpieces and candy hearts that are littered about for the kids to munch on and wonder, what's going on with my teacher today? She's lost it. And that's kind of what our whole purpose was. So we are thinking, how do you help kids do well with constructive response? The meat of the situation for us is you have them ace it. We're using the acronym ACE. And for us, it was the Ace of Hearts. That was really important to us. ACE it? What is that all about? Well, how do we implement a process like this? Well, for us, ACE stands for 3 very simple things. A stands for answer the question. C is either cite or choose your plan. And E is explain your reasoning. So those 3 things go with ACE. So we turn it into an Ace of Hearts situation so students remember. And one of the things we would do is have a poster such as this in our classroom, hanging up, and you make them yourself, and you can make it as decorative as you want. But notice we pulled off of the Ace of Hearts idea, and we'd have the ace sitting around our Ace of Hearts. So when the kids say, well, what is this acing situation? Well, it's all about the Ace of Hearts. And you see on here we have answer the question correctly for A. For C, it is show all your computation, a C word. Pick the correct operation or plan, or choose the correct plan is another thing that we say. And we gave some examples of some plans there available in mathematics. And then for E, E is explain all your steps and why you chose them. How does your solution answer the problem? And then of course use an estimate to show how it is correct. Now the estimate isn't necessarily going to work for all of the problems, but it does work for a lot of them. Now some teachers ask us with that ACE situation, they're like, well, answering the question first, in mathematics, don't you have to choose your plan or do your computation or write about your plan? Honestly, when we look at brain research for students and mathematics, what happens, the brain tries to make and come up with an answer immediately when it reads a question. So when a student reads the question, they already are trying to calculate the answer. We encourage that, that's fine. Try to answer it. And so doing, you're writing out your plan. And when you're doing your plan, you're doing your computation. And you're always examining, well, is that the answer? And then maybe I need a new plan. So that process is very cyclical. And we ask the students then to explain their reasoning, and that makes them decide whether or not that is the correct answer, and then that can help them in choosing a new plan and then explaining. So that process isn't always just choose your plan and then it doesn't go linearly. It is a cyclical process. So therefore, we put it in a heart so our students should know that they can try to answer the question correctly at the very beginning. So beyond just introducing that poster, how do you get this out to the students? In the packet of resources that we have on the website for you, one of the resources is a flowchart. And the flowchart is pretty extensive, and it runs through how do you get this process going to your students. So right now on the flowchart, I am on the first horizontal row of the flowchart, and that starts with introducing the ACE poster and concept to students. So when they come in, they get to see the poster, the little candy hearts make a big impression, and we talk about what A stands for, what C stands for, what E. We could even, under the C section, we can talk about appropriate plans. Under E, we can talk about we have to write about our response. But basically, you're going over the poster, hanging it in your classroom, letting the kids see it as often as possible. We also have a version of the ACE poster that is a handout for the students. The second thing we do is we have students set up their own folder. Our vision on that is that students keep a constructed response folder for the entire year. And you can even go with them into the next year and the next year, and it can become a portfolio of sorts of constructed response for students. So one of the things we did, and of course I asked my own children to do their own drawing, so this is by a 6-year-old and a 9-year-old, but I asked them to design their own folder with Ace of Hearts, which they did. And then of course, I put the name on top so I could read them and keep them alphabetically. And Deborah's and my vision was to have a crate off of the side of the room where students would store their folders and leave them. And when they saw that it was an ACE day and they came in and they heard the love songs playing, they would go and grab their ACE folder, bring it back to their desk, and know that they were going to either do a constructed response or do some sort of grading or initially adding to their folder. This one on the inside has a lot of stuff added to it, and we're going to talk about where that stuff comes from. But each student gets their own folder and their own things so that they can look and refer to them when they need to. The second thing after students set up and decorate their own folder is running through a constructed response. For us, when we thought about introducing constructed response to students, what we were thinking is that we needed to start someplace safe. Students are very unnerved when they see a problem that is in detail and in depth, and if they see it for the first time on an exam, that can be very stressing for them. So we decided, Deborah and I did a good look at children's books and how children's books can be a good introduction into solving problems. So for the mathematics portion, we chose The Grapes of Math by Greg Tang. And what I decided to do as part of this lesson, it's a pretty long book and it has a lot of problems in it. But one of the things about the book is it has a picture from the book. There's a really neat illustration. And then the book has a poem listed in the book. And the poem goes on, and this is written down for you. There's a poem in there, and there's a question about the picture. And then it also gives you a hint about an alternate way to solve the problem. So there's a lot of them in this book. They're really fun for kids to see, but they're not something that they would have trouble solving at any age, including 3rd grade. So the question that I would give the students, and I chose one called For the Birds. Before you have too big a clan, it's good to have a housing plan. Instead of building one big nest, lots of small ones may be best. How many eggs are in this batch? Count them quick before they hatch. Here's a hint you can't ignore, adding's fast with groups of 4. All right, so here's what we would do with the students. We would hand out This is our copy. It's in color, and it certainly wouldn't need to be in color for the students. But it has the ACE poster for the students, a little bit smaller for them to put in their folder. And then down here is the question that I just read, that it asked about the how many things in the batch. And I'd leave the picture up, and I just scanned it and put it in a PowerPoint for the students to look at. And one of the things we talk about is, how would you answer this question? And I would lead the students directly through how would we answer it? Because here's the deal. If you have a special ed student, if you have a very low-level student or English language learner, you can count the eggs, 1, 2, 3, 4, 5. And that is an appropriate plan. And that's an okay plan for a student to choose. However, the problem itself leads you to hint that there's something else you might do. And so we would generate those answers as a student, as a class. Even in secondary, in 7th and 8th grade, it's an easy problem. Kids can get behind it. They can start thinking outside the box, and that's what you want to encourage. What I really like about this book is how it writes the answers. And what I would lead the students to do, and in their folders, they would be writing this answer in their folders as an example of a perfect constructed response. So here's what the author did. They gave an answer. The answer, as you can see, is 36, and the student would write that in their answer box. The computation, 12 plus 12 plus 12 equals 36. That's part of the computation C section, or choose a plan. The other thing this person did was draw a picture, and drawing a picture is an appropriate plan. So I'd ask the kids to draw a version of this picture. They could do it with little dots and circles and that kind of thing, but the author actually drew what was going to happen with the plan. And the last part, the E section, is he explained his thinking. He didn't just leave it at the picture and the computation, he explained it. If you move 1 egg from the nests with 5 eggs to those with 3 eggs, then all 9 nests will have 4 eggs. Each row of nests will have 12 eggs, so there are 36 eggs altogether. 12 plus 12 plus 12 equals 36. This, to me, is a perfect constructed response, and students need to see one done correctly, and that's going to be really helpful. So depending on the age of your students, this and doing this example and having them writing it down and putting it in their folder might be enough. However, if students are low level, if they are much younger, you might want to grab the grapes of math and maybe make centers up. Basically, the paperback version of this book is very inexpensive, and you could open it up to different pages and have students visit different centers and see if they could start to practice writing a constructed response, and then be able to look at the answer sheet and see how they did. But it's a great starting point. Okay, after you have introduced constructed response to the students in this way, it is time for the students to look at how constructed response is graded. They need to see what good work looks like. In the packet, you can give any problems you want, but what I did is I went to the mathematics sampler books. They are done by NCTM, and they're listed in our paperwork, so you can figure out where to get them. And you can only get them on NCTM, not Amazon.com. But there's 3 through 5, and then there's 6 through 8 or something. Yeah, 6 through 8. So inside those samplers, they have constructed response questions, which we really like, but for copyright's sake, they are not in our packet of papers. But you grab a constructed response, and you hand it out to the students as a group. You do this as a whole group setting. Once they've seen the problem, as a class, they brainstorm a solution as a group. And I picked a problem that if you were doing this in 7th grade, it was a 6th grade standard. So every student would have been exposed to it. Together we brainstorm a solution or possible solutions as a group. Hopefully the problem has more than one possible solution. I mean, more than one possible plan, not necessarily solution. As a class, we'd understand which appropriate plans would work. So we would have these discussions, we'd map them out, on an overhead or a smartboard of which plans we think would work. Then students would need to see copies of student work on this problem. So inside the mathematics sampler is really incredible. They have student work actually written out, and it tells you at the top if the student had complete understanding, partial understanding, etc. However, I wouldn't give the student the answer whether or not they had complete understanding. I would white that out and just give the student work. So we give the student the copies of student work and let them assess. What do they think? How do they think the person did? They're going to have to sort that work into different piles. Did the student get 0 points, 1 point, 2 point, or 3 points off of that work? And how do we decide how many points they get? Well, using the ACE format, Deborah and I came up with a response page to the constructed response. And what we did is we put the ACE format in the poster, and each one of those will get a direct point, which is basically how they're scored. It just looks a little different from an instructor point of view. But for the students, this is what they're looking for. So on an A, the question is answered correctly, they would mark yes or no. For C, they need to have both of these sections, and that's why I wrote on there the author must have both. For E, every step explained and it's clear, the details are clear, the person went back and answered all parts of the question. Those 3 things should be apparent to get the E. If there is a possibility of an estimate and it's explained, that is wonderful. If it's not there, that's fine. But what the students would do is they would look over these copies of student work and decide if the student work got 0, 1, 2, or 3 points. And they'd sort them into piles. Then as a class, we come back together and discuss. Which one did you give? You gave student A, did you give them 1 point? And as a class, we discuss why they would just see those points. So the students can really see how the grading is given and what the points are. Now that a student has seen a good constructed response work through, and they have seen how it is graded, now the important part is you need to get a baseline. You need to see where the students are at. You as the teacher need to assign a problem, something that they've just gone over, some material that they've just learned. The students have to do it on their own. No discussion as a class first, let them just try it. You as a teacher need to grade the problem using the evaluation sheet. The evaluation sheets look exactly like our poster, the peer response, except it says teacher response at the top in the packet. So it's going to look exactly like this. The teacher has the exact same one for the students to use. The teacher, you can have the students graph the results, but sometimes that can really pull out a safety issue. So a lot of times we recommend the teacher graphs the results of the students doing those problems, and then we're going to set a class goal. Once the teacher has charted the student progress, what you would do is have a big chart in the room. And Deborah is going to show you in the English section of different ways that you can do charting depending on how many students you have, how many subjects you teach. But for this case scenario, if I was looking at this individual class and I had their results posted up here, I want to caution you, please don't use their names. That can be really hurtful. But we look at it as a class and say, okay, this is our very first constructed response. This is our baseline. So it's a great mathematical exercise to do some data analysis. What is this telling us? And for us, it would say, okay, we've got some growth to do. And not to be judgmental to the students, but to say, we need to set a goal as a class. So what could our goal be? And let the students set that goal. Whether they say we want everybody to be up by 1 each time, we want all of the students to be at 2 or above, whatever their goal is, encourage them to make a goal that's reachable by a timeline, and we would make it and actually set it up and add it to our charting our progress so the students could see it every time. We're going to talk about charting again, and when we do chart again, I'd recommend using a different color of Post-it so you can kind of see the second time maybe they're green and the third time maybe they're yellow, but so you can kind of see that how we are getting toward our goal. The next thing that we're going to talk about is our problem and assigning problem. We have like a cycle that Deborah and I feel works pretty well with the students. They have to have some time to stretch their wings a little bit before and not get assessed every single time. It also lightens a lot of the load onto the teacher. First of all, we would say our cycle is this. Students do a problem, someone evaluates it, fills out a check sheet for them, and then the student tracks their own progress. So with that in mind, before we talk about the specifics of that, let me show you some of the forms that we would use to be able to do that. For a peer, once you do your problem, there's a form for a peer evaluator. And what we did is we made it small so you could fit 4 on a page. And the peer evaluator, this is the teacher response. The peer one looks exactly the same. It just says peer response to constructed response. You can just cut them. And the peer fills it out and gives it back to the student when they're done. So these little forms are exactly like the poster we talked about earlier, and it's the exact same form that the teacher is going to use, so the student gets familiar with them. The next thing I mentioned up there was charting your progress. And one of the things that we are talking about in all of ours is that students are going to need to chart and really reflect on their progress. So this is a piece of paper that's going to go inside the inner part of their folder, like this. So it's this form right here. This was the original constructed response with the grapes of math that we did. So they have those two things. And this is where they're going to keep track of their own work. So on this charting their response, a student is going to put down the assignment, the date it's assigned, and then they are going to grade themselves. They're going to decide if they really feel they did well for A, for C, for E, what part that would they give themselves a point and what score would they give themselves. And then when their peer evaluator looks at it, that's the second line, and the peer evaluator is going to give them something off of their check sheet, and then the student's going to have to go back in and fill it in at what their peer evaluator told them. This section right here is for the teacher to do and for the student to chart what the teacher said. This middle part here is for the student to reflect on how they did in this chart. We did include for you in the packet of information an example or a sample of a chart filled out. You might have to model this for the students so they can see how it needs to be filled out. And we put the problems and we showed how a student was being evaluated, how the teacher evaluated them, and what their reflection looked like. So those two things are in the packet. The other thing we do have in the packet also is if you have any advanced students, you have students that are working at a little bit faster pace, maybe they were scoring 3s on the constructed response immediately, maybe they need 2 peer evaluators scores. So they're going to have to get 2 kids to evaluate their work so that they're charting themselves a little bit differently than everyone else. Or your entire class can do 2 peer evaluation scores on occasion. Once students do a problem, we don't want them immediately to give it to the teacher and have the teacher evaluate. So our benchmark was after 2 problems, then the teacher would do the 3rd and collect the 3rd. So one problem the student does, a peer evaluates, the student gets it back and has a chance to reflect on it. Then the student does another problem maybe a week later and a peer does it and evaluates it and gets it back. The 3rd one is when it goes to the teacher. So the student really gets to see their growth, they get a chance to practice a little bit, it's not always so high stakes. As far as the peer evaluation, after the peer evaluation happens, one of the things that Deborah and I were really specific on is that students need to be able to practice this like they would see it in a testing situation. Unfortunately, most of our students see a constructed response for the first time on a benchmark exam or on a state exam. And what we were kind of concerned about is that most of them saw the paper and didn't know how to deal with it. So what Deborah created, which is amazing, are these scaffolded answer sheets. Because in the mathematics portion, it comes on a grid. And what we noticed is students wrote in the margin because they were afraid to write on the grid if it was not a graphing problem. They just didn't even understand the paperwork. So we thought it was really important that students do the work on the papers like they would see it in a testing situation. And what we meant by scaffolding is the very first page in the packet has the A and the C and the E written there for the student. And then the reminder, what A stands for, what C stands for, what E stands for. So if a student is really struggling, has been getting 0s, this might be the perfect way to scaffold. If the problem has 2 or 3 parts, it might need lines drawn down the middle and scaffold it even further. But the way the scaffolding papers work is you can tell the A reminder dropped off on the next scaffolded sheet. Then the C reminder drops off. Then the E reminder drops off for the student. And then they're just left with A, C, and E just to help them keep themselves organized on the paper. And the last one, it looks like it does on the test, with the exception, of course, of the hearts, which is our gimmick. But this way, they can be at whatever level they want. So you might have some students at the beginning scaffolding and some students at the very end. And it just depends. You just make a bunch of copies and let them choose where they need to be. Sometimes they'll need to move backwards, sometimes they'll stay where they are. We also thought an important portion of this for the students is there's a rubric given on our state CRT in Nevada, and it comes before the constructed response, and students look at it. It's written for adults in adult language, and students see it and have no idea what it's even saying to them. And so a lot of them see that and skip it and move on and don't even fill out the constructed response. And what we wanted to do is, because ACE is so non-threatening, is we wanted to continue that non-threatening behavior for the students with the rubric. So what we would do with a rubric, in your handout is a copy of the actual rubric from the state of Nevada, and it gives the adult words for the rubric. And what we would ask the kids to do underneath it, and there are some sections for them to do this, how is it similar or different from our ACE framework? So what they would do is they would keep that information, they would look and they would write, this word seems the same, that word's different, and I don't know what this word means. It gives them a chance to look at that rubric, to take it apart, to put it in the ACE format. So at the end, the aha is supposed to be for the student, oh my God, that's just ACE. It's no big deal. It's just adults talking to me, and I'll just ignore that. So when they see it, they're not going to be threatened by it. We recommended that no matter when you are introducing ACE to the students, that you always do this activity somewhere, that they get a chance to change that adult talk into kid speak, and that does end up in their folder when they're finished. We are insistent that students chart their own data, that they keep track of what they're doing, and then on occasion, you as the teacher chart it. So we keep track of the charts, whether on the posters with Post-its, or Deborah's going to show you an alternate method to do it, but you are, every time the teacher collects, that they're going to be charting the data as well. The most important thing, you've got to celebrate. Part of the gimmick is to make it a big deal, to celebrate even the tiniest little successes that the students are making. If they're making great strides, set a new goal. Maybe that goal wasn't high enough and we need to go back. But this part of data analysis loop is really important for mathematics as well. So it ends up hitting a lot of standards when you do this. So how do we get these constructed response problems to assign? One of the things mathematics teachers tell me all the time is that there's too many standards. They have to cover so much in such a short amount of time. So one of the things that I thought of is how can you put in constructed response and not derail your curriculum? What I decided to do, and what you see in your packet, is I went through the 7th and 8th grade standards, and I broke them up by when they're supposed to be taught according to the course guide. And I found constructed response problems in these two texts right here, and said it's this problem on this page. And I tried to give as many options for each standard as I could. Some of them have student work attached, so that would be a time that you can always go back and have the students recalibrate whether or not they're grading them well, if they need to look at other student work, if they just keep seeing the same student work over and over again. But we picked problems out of here so the students could do it, and you could keep it inside the curriculum you're supposed to be teaching so they can practice. They're also in your handout, done by Maria Munez, our K through 6 math coordinator. She did it for all the grades, 3rd grade through 8th grade, every 9 weeks, so that you can go back and make sure your problems are matching up to the curriculum you're supposed to be teaching. Unfortunately, some of our standards don't lend themselves to constructed response problems, and they don't have one that we could find, and that might be something that you in a PLC could write on your own. The next question begs, well, where else can we use ACE? Here's math, but wouldn't it be more powerful if we saw ACE in all of our topic areas, and so the students become so familiar with it? It's not a gimmick in Miss Young's crazy math class. It's a gimmick that you use throughout all of your learning, and that comes really easily when it's time to take the test. So Deborah's going to take us away into English.
Done with all that dry math stuff. I'm just kidding. I have to give my partner a hard time because I'm an English type. Let me talk to you about English and how we do constructive response in language arts, which is really fabulous. The first thing you want to do is look at the heart with the kids, and they all have it in their folder, like Holly showed you earlier for math. It's a little bit different. I had to have Sum It Up in there as an English type. I just couldn't stand not having them wrap their paper up. So forgive me, it's the only one that's a little bit different. The first thing you want to do is go over the heart with the kids. Make sure that they understand all the vocabulary. Because I found when I did this in the classroom that some of the words that I thought were the simplest, they had the most trouble with. They were good with answering the question correctly. That one they were fine with. Here's where they got into trouble. Cite multiple details from the reading in order to show your understanding of the passage. I said to them, okay, who can tell me what cite means? No hands. Seriously, you guys, who wants to volunteer? Tell me what cite means? No hands. So we went over what does cite mean. You find it in the text. You want to have it show up in your paper. So then Holly and I thought, you know, this would be a perfect time for some whole class student engagement. So what we're going to do, and we can do this with every content area, is you have the kids do this movement. You see it here, you write it here. You see it here, you write it here. And you do it enough times, and Holly came up with a great idea that every time you say the word sight, all the kids are doing the motion. I thought that was fabulous. Once they understand sight, get the details, you move on to examine your answer. Have you addressed all parts? If they're like me, you know, if somebody asks me a three-part question, I'll usually either answer the first part or the last part, not all the parts. So we really go over, have you addressed all parts of the question? And then the last for English, of course, is just sum it up, wrap it up, end it. So that's the first thing you want to do. Here is the flow chart for language arts, and this is another funny story. I don't know if it's just me, but as a language arts type, I hate flow charts. There's just something about them. I don't get them. I just hate them. So I came up with a, and if you want it, let me know. I hate flow charts directions. So what it is just basically this, but written out so that other people other than math and science types can understand. So how do you start? What do you do? Holly and I decided, you know what? Let's start with something simple. No matter if you're elementary, if you're middle school, if you're high school, if you're SPED, if you're ELL, everyone can start with simple and non-threatening. So we decided to use the book, The Paper Bag Princess by Robert Munch. And the reason we chose this one was because it really has a really fun ending. I'm not going to ruin it for you, but it has a fun ending and the kids like it. So what I do is, I know Holly talked about scaffolding papers, and here's the scaffold for the very first scaffold. Now, like in math, certain things will be taken out later. On the second one, it doesn't say answer the question correctly. I think there's just an A, and then it moves into just a C, just an E, and then finally it's just a line so that it's looking just like the test. So a good way to do it is scaffold, or if you have higher level kids, hey, you don't need to start them on the first one or keep them on the first one. Move them on to the third, the fourth one, you know, move them along. Save these kind of things for your ELL, your SPED, ones that need a little bit more help. So I say to the kids, all right, you guys, here's what I want you to do. I want you to fold your paper hot dog style. Do that for me, okay? They're all folding it. They understand the whole hot dog style direction. And then I say, oh, by the way, what is the very first thing? We've come to the constructive response portion of the test. What's the very first thing I should do? And they're pretty good at coming up with, you're supposed to read the question. Great. Let's read the question. Is the princess a weak and stupid person or a strong and smart one? Give at least 3 examples. I make them underline or circle 3 so that they really remember they need 3. And then I say, close your paper. On one side, I want you to write weak and stupid. And on the other side, I want you to write strong and smart. I don't care which side, just write it on the top. Okay, they do that. And then I say, what we're going to do is, I'm going to read you a story. And you you are going to jot down ideas. And jot is another word you're going to want to go over with them because I found that they really didn't understand jot. So we go over jot. They write down just, you know, little notes on the back of their paper. I'm done with the book. A good engagement strategy is to say, okay, you guys, on the count of 3, if you think the princess was weak and stupid, raise your hand, palm open. If you think the princess was strong and smart, palm closed. Weak and stupid, strong and smart. You ready? And no answer's wrong, as long as you can back it up. Ready? 1, 2, 3. Then you have everybody engaged. It's a nice little way to get them all involved. The next thing is we say, okay, now what we're going to do is we're going to go ahead and we're going to answer the question. Some of you, especially in the lower grades, might want to go over the answer the question correctly or the so, how to wrap it up. And really all they need here is, you know, in this story the princess was strong and smart, or in this story the princess was weak and stupid. Just really simple. There are 3 examples, and on your paper you can see that you have a lot more space than on this one. and then wrap it up. So that's why I believe that the princess is whatever they've decided. That's pretty easy, very non-threatening, everybody gets it. The next step is to look at the checklist. How exactly am I supposed to decide how many points I'm going to get? The writer's name goes here, the peer's name goes here. Now, what I had them do in a classroom is the very first person who's going to look at this is going to just put a little X in whatever space they think they got. And the next person, the peer, the reader, is going to circle the box. That way you can really tell and really have a good discussion. I'll say, you guys, once you've done this, if your answers are different, discuss why. How did you come up with different answers? But and to get A, you have to have just one thing. To get C, notice you have to have two different things. You have to have details cited and enough examples. And to get the ES, every part is addressed and answered. There are no unrelated and inaccurate details. And by the way, sometimes you have to go over unrelated. And then the paper is summed up. Now, does everybody understand this, I asked them? If they say yes, we move on to some examples. And the reason we want to do examples is because not so they see a good paper, but so they know how to score papers. So we'll put up, 3 or 4 examples, and I will have them again, after we read this, everybody raise your hand. Is it a 0? Is it a 1? Is it a 2? Is it a 3? What do you guys think? Why? And they really get the idea of what makes a good paper, what mistakes people can make, so then they can go back to the checklist and really fill this out. After this is filled out, they're going to give it back to the original writer, and they are going to chart it. I put one of these, I hope this is big enough for you to see. I put one of these on the overhead, and I go through, first I show them an example. Here's an example of how a paper might be charted. And then I don't just leave them with that. I actually write the paper bag princess, the date, what I might get, so that they understand that this first line is theirs. What they really need to understand is that do not write if it's pink or if it's shaded, don't write in that area. That is not your area, that is the teacher's area. So they are going to chart what score they gave themselves, we can cut that out, what score they gave themselves and what score their peer gave them. After 3, the teacher is going to score along with the student. And this makes it really nice. You guys don't have to grade everyone. Don't kill yourself. Okay? Here, I know Holly mentioned that I was going to show you a different kind of score chart. And this is it. Notice I put in up here period 1, period 2. So if you're middle school, high school, you're probably going to do it that way. If you're elementary school, you might want to put math, science. Then, for instance, this blue would be period 1, and you could put in with a dry erase marker the score the class got. Period 2, period 3, etc. If you wanted to do, if you're an elementary school teacher and you want to do a math line, a science line, a language arts line, you could do it that way. This is just to give you guys an example that there's more than one way to chart. And like Holly said, celebrate. Even if you're moving, okay, nobody has a 0 next time. Little steps, baby steps, really, really celebrate with the kids so that they get excited about doing even better the next time. Somebody asked me, Moreno, this is great, but my kids are 8th graders. When they go to high school, they're not going to have constructive response. So why should I even bother with this? So I thought about it, and I found this by Ardith Davis Cole. And what it does is it shows on the left side what it would look like as a constructed response. And on the right side, it shows what it would look like if you turned it into a paper. So good writing is good writing. You just add some more details, fatten it up a little bit, and then that would make it a good paper for high school. So that was the answer that I came up with, and thank you, Ardith. Holly, I know Holly mentioned that sometimes these rubrics are scary. The kids, they look at the rubric and they go, I don't know, I'm not even going to read it, I don't understand it. So before they take the test, there's a paper in your packet that's called Kid Speak. And you're going to want to change this into language that they understand and then say to them, see, it's the same thing. They're just trying to act all highfalutin over here. You guys know what you're talking about. You guys know what you're doing. So don't be scared. Don't let them scare you. You can do it. And now, Hallie is going to explain a little bit about science.
For the science portion of ACE, it should collaborate pretty easily with English language arts and math. So when we took a look at the ACE poster, what we did, some changes that we made here, we still have the basic ACE of Hearts, so you can keep that whole theme going, especially if you're in middle school and you're on a theme day, or in elementary school. You can bring it up in all of the subjects, actually. But we still have the same situation. So A is answer the question correctly, the same for all three. The C is the same for English, which is check and cite. So once again, we're talking about a new word. And Deborah mentioned in English language arts, but if you didn't see it, the best way to introduce cite to your students is to do hand motions. So her idea is cite, which kind of sounds like it, so you see it, cite. I see it on the paper and I write something. I see it and I write it. And one of the games we'd like to play with the students is every time you say the word cite, the students have to do the motion. And it can get silly and fun, but they'll remember what cite is. So you see it in the reading and then you write something. So for science, we say that you need to check and cite all supporting information. A lot of the science constructed responses use graphs, text, and or diagrams, so they can use a lot of information, and we want the students to really look into those pieces and decide what is important, which ones I'm going to use. Then E, again, is explain your thinking. When you give an answer, you need to give all the reasons why that answer is correct. And then we have a last part, which is the same as English. Examine your answer. Have you addressed all parts of the question? Science typically has 3 to 4 parts, and you need to make sure that the student has answered all of them. So in science, after we set up our ACE poster and we introduce it to the students, of course we'd want them to set up their folders. In elementary, they'd already have them, but in secondary, they'd want their science poster. First thing you should do, the students with the constructive response, remind them is to read the question carefully. So the question that we have is, using the book Salamander Room, list 4 of the most important parts of a salamander habitat and explain why salamanders would be dependent upon them to survive. Start off the book, we'd grab a scaffolded answer sheet. Deborah has created a lot of different scaffolded answer sheets for science. It starts out with the A, C, and E and the reminders for each, and then slowly takes each part away. But I'd start with the first one that has the A, C, and the E and the reminders on it. Give that paper out to the students with the question for the salamander written on it, and then have them fold the paper in hot dog style and then hamburger style, so that the paper is broken up into fourths. They turn the page around backwards, and they're ready to jot down the 4 important parts of a salamander habitat. Jotting is an important skill that students need to learn. They're not trying to write everything you say, but they need to write down little ideas. And it's a good skill that can feed off into English language arts as well. Once they're ready, we'd read the story of the Salamander Room. It's a totally cute book about a little boy who captures a salamander and wants to keep him in his bedroom. The mom keeps giving him reasons why the salamander won't survive. He needs friends, he needs food, whatever, and the boy comes up with solutions. Well, he'll just make a pond in his room, he'll plant a tree, he'll bring the birds in, etc. Until what happens is, in order to solve all these problems, the boy eventually ends up with an entire outdoor habitat within his own bedroom, because the salamander would never survive. What we'd want the students to do is to jot down their ideas and come up with some ready thoughts about how to write this constructed response. So once they've jotted down the idea, we're going to ask them to write their response using the ACE format. So using the scaffolded sheet on the other side, write up a response to our question. Once they've written a response, we sort of take a break from that and we look at samples that other students have written. The samples themselves are on the same question, and what students would do is they would look over the work and you'd take off how much credit it got. The students would have to come up and look at the peer response sheet and decide how many points the students got on each one of these. So together you can work as a class to see if they can sort them, have a great discussion about what gets a 3, what gets a 2, a 1, and a 0. So the students have some initial schema on grading constructed response. Then what you want them to do is to grab the peer check sheet and respond to their own writing. Look at their own paper that they wrote and what points would they give themselves. Would they give themselves a point for A, a point for C, E, etc.? And they'd fill that out. Then we'd ask them to exchange with a peer and have a peer respond to their paper and then fill out what they feel the student got on their paper. If they don't agree, this is a chance to have a great conversation and have the students really analyze why they didn't get a point or why they did. The next step is for the students to chart their work. Remember, Deborah came up with this chart right here. You could also have one chart per class for you to keep track of how many people got 0s, 1s, 2s, and 3s. It's a really good idea for the students to see where they're going, and then they can, as a class, can set a goal. Do we want to make sure everybody goes up by 1, everybody gets better than a 2? They need to set a goal. It needs to be put up here so the students can see how they're doing. Some things that some teachers have been doing is competing within different class periods. If it's a secondary class, competing against the classroom door, that always shows as a good motivator for students. They seem to enjoy that very much. Our next question is, how do we deal with the older kids? When it gets to 7th or 8th grade, science is a little bit more difficult than the children's book.
Okay. I was just in an 8th grade science classroom a few days ago, and this prompt worked really well. What we did is we talked about heredity. Now, as 7th graders, they had learned about heredity, so the first thing I did is I reviewed a little bit. That whole, you know, if your parents have brown eyes or blue eyes, what's going to happen, which, by the way, a teacher did tell me that a question came up about, well, my parents both have blue eyes and I have brown eyes. And the teacher really tried to skirt that issue and say, oh, maybe you should go home and talk to your parents about that and see what they say. So I thought that was kind of funny. I was glad that when I was teaching the class, that didn't come up. So again, you share the ACE poster, and I know Holly did that for you. So she did a fabulous job on that. Whole group practice. I'm going to go through a whole group practice for you. Write the responses, peer responses, the same thing as all the others. This is the beauty of it. The kids really get used to it, class to class to class to class. So let's look at what we might do with the 7th or 8th graders or 9th, 10th, 11th graders. Here is a Punnett Square. So the first thing I do is I put this up on the board. You can, and by the way, our science teachers, so if your science teachers have those active boards, the kids love those. That really gets them involved in this. But to tell you the truth, the teachers who had whiteboards, the kids had just as much fun. So what they're going to do is they're going to come up. I'm going to say, hey, come on down. The first kid is probably going to fill in this square, y. Now they're going to explain. Well, how do you know which letters go here? So they're going to actually explain that. Then I'm going to ask them, is this a dominant or recessive square? They're going to tell me dominant, and they're going to say, because there's a dominant there's a dominant trait in here. And if there's a dominant trait, and by the way, we all said this as a class, the dominant always wins. Really get them going on that. They have a lot of fun with it. And then we continue forth. We get done with the chart. The second part is I want to know how many of these squares are dominant and how many are recessive. And the third part is just like on this chart right here where it says explain your thinking, examine your answer. That's what we're going to want them to do. Back over here, right here, what they should have written is 75% of the squares are dominant and 25 are recessive. Notice on this part of the question, they're not asked to explain anything. This is still part of answer the question correctly. Here's where the explanation comes in. I know, and always tell them use the word know, because if they say I think, then we think, I wonder if they know or they're just guessing. So say I know. I know the 75% of the Punnett squares are dominant because there is a yellow P or a dominant trait in 3 of the squares. And whenever there's a dominant trait in a square, the dominant always outweighs the recessive, or the dominant always wins. I also know that 25% or 1 square is recessive. It only has green P's, and because it only contains recessive traits, it's recessive. Then I say to them, you know what? Look back to your question. Because remember, and I'll say to them, oh, are you guys finished? Remember, if you're finished, go back after E, go back to E. Have you addressed all parts of the question? So then I actually stand up in front of them. I pretend like I'm reading the question again, and not just going like this, writing, done, because we know that's what most of the kids do. So I actually get up and I tell them exactly what I'm thinking. Okay, let me see. Have I answered all the questions? Let me look back to my P chart. Okay, let me see. Y, G, G. Okay, I'm good on that. Let me just make sure I know. Let me see. So that has to be dominant. That has to be dominant. That has to be dominant. So yes, 3, so 75%, 25. Okay, I'm good on that part. Now let me make sure, have I explained my thinking well enough? Have I given enough details? I know the 75% are, and this is where, let's say they didn't put the yellow P part in, they could add it. Tell them add it. Add information. It doesn't have to be neat, it doesn't have to be tidy for a constructive response. So add it in. And this is your chance to check it, look it over. Have I addressed all parts of the question? You know? I think I have. So now, just like in every other class, you are going to look at your paper, respond, look at your peers' paper, respond, chart your results, but most importantly, scaffold. Because if they never get to that one that looks like the test, they're not going to recognize it when they see it come test day. So really, teachers, this is actually the hardest part to remember, but probably the most important part. So remember, you guys, make constructive response fun. Be dorks. We're dorks. Be dorky. Be dorky. Wear heart jewelry.
Wear red. Be crazy. Maybe give out heart stickers.
Oh,
yeah. Big heart stickers.
Play love music. That's my favorite part, Holly.
Yes, we always play love songs.
Yeah.
We recommend LOVE by Natalie Cole.
We love that one.
That one's our
That's
favorite
a good one.
We like to have heart candy after Valentine's Day. Go and stock up. It's like 75% off. We get all these candy hearts, and maybe every time we have a success, we give out a little bit of candy there. It's curricular in nature. It fits the healthy food requirement.
And you know what the favorite part for the kids were? I don't think I told you this, Holly. When we played the LOVE song, we were doing the whole YMCA only with LOVE. It was so much fun, and the kids kind of remembered.
I think they would.
Why we were doing this and the whole gist of it.
Or they can even do with LOVE ACE as well.
Good idea.
Right?
Really good idea.
Yeah.
Really good idea.
On Oriental Trading, they have gummy ACE parts that you can get to if you've got loads of money, because all teachers do. But we say you make it as gimmicky and as dorky as you can get it, whether it's red and white balloons or anything crazy. Decorate your classroom, have some fun with it, and the kids will get the gimmick.
They really will.